seems a little odd in a way because salt is really a molecule in the ocean water. But collectively, that salinity plays a role in the ocean circulation.
It's these differences in salinity that play a role in the processes that affect weather, climate, sea life, and the whole ocean system itself. And not all oceans have the same salinity. In fact, the North Atlantic Ocean tends to be the saltiest, much more than the Pacific.
The salt in the ocean affects its density, just like the temperature affects its density. And the density, meaning the amount of mass per volume, is going to then impact where the water goes as it circulates throughout the globe.
Differences in temperature and salt content of the water cause some areas of water to sink and some areas of water to rise. And so we tend to see the sinking water at the poles, the water rising back up at the equator, and if you connect the two together, what you have is an overturning that's deep in the ocean. It's like a big conveyor belt that operates in the ocean.
This overturning moves warm water from the tropics toward the poles and cold water from the poles toward the tropics. In this way, the overturning regulates Earth's climate.
And the atmosphere and the ocean, both being fluids of the Earth, really work together. We consider them sort of equal partners in the redistribution of this heat on the planet. So when those warm waters are returning, as they're moving up to the higher and higher latitudes, then they're releasing that heat to the atmosphere. Then the winds blow over the ocean, they pick up that heat, and those winds over the Atlantic Ocean are moving from the North American continent to the European continent.
It takes perhaps 1,000 years for the water to cycle through the deep oceans. And so we said the oceans have a memory. They're like a tape recorder. Things that happen now will still be manifest hundreds of years in the future as that cold water moves through this giant circulation.
So if there's any change to that overturning circulation, that means that Northern Europe and the British Isles would be robbed of that heat due to those waters that are returning to the high latitudes.
The oceans are vast, covering 70% of our planet, and so it is no surprise that we still know only a little about this system and how it will respond to change and furthermore create change.
Climate change on Earth is complicated by the fact that the ocean moves much more slowly than the atmosphere. So you have warming in the atmosphere, warming in the ocean, but they're occurring at different speeds. So they're out of sync. And that makes predicting what's going to happen in the next 102 years very, very difficult.
Now, what we might expect happens in a very simplistic sense is that as the ocean warms, there's going to be more evaporation. And that more evaporation would mean that the oceans become saltier. But really, it's not just that simple because there's also evaporation, precipitation, and the ice as well, and that's all wrapped up in the study of the hydrologic cycle.
People have been measuring salinity for centuries, but ships and buoys alone cannot match the perspective from space. In fact, a whole quarter of the oceans, larger than the size of Africa, have no salinity data at all.
Up until now, when we've been trying to understand how density changes impact ocean circulation, we've really just had half the picture.
When the Aquarius satellite is launched, scientists, for the first time, can look at salinity of the surface of the ocean from 400 miles above the Earth.
But now with the Aquarius mission, we'll be able to complete that other half, and we'll be able to look at the salinity information. And so salinity combined with temperature will give us the information about the density field.
In the first 2 months of Aquarius's launch, the satellite will gather more salinity data than in the last 125 years. This mission will help scientists better understand how salinity and ocean circulation are tied to global climate, and how both systems are changing throughout time.